Assalamu alaikum dear students, how are you all? So welcome back to my computer science club. Today what we will learn is that we will learn about stepper motor. So we all know that when the theory of rotation comes up, we all have motor in our head. There are some motors which rotates 360 degrees continuously. These are very cheap motors. Most of the motors of this kind are having errors or other kinds of. The most accurate motors are the motors that rotate per degree as per assigned to them. There are some motors which will rotate 15 degrees, 18 degrees. If I assign 15 degrees to it, it will rotate 15 degrees. Now the question is how the motor will understand that what degree I need to rotate. There are a lot of programming over there, but before programming in this video, I want to make you introduce about the stepper motor. So let's start without making any delay. Stay tuned. This is also an underrated video. You will not find this kind of video anywhere elsewhere in the YouTube. As I have googled it, I came across the problem. So for this reason, so that you don't come across the same problem like me, I made this video. So let's start with the stepper motor. So the stepper motor accomplishes its task by mainly two ways. One is half step, another one is full step. So at first let's talk about the full step. So what happens in the full step? In the full step, alright, before going to the full step, let me give you a brief architecture of this stepper motor. In the stepper motor, there are 4 coils. This is coil number 1, denoting by A, coil number 2, coil number 3, coil number 4, B, C, and D. Alright. So now, I'm placing a magnet over here. This is North Pole and this is South Pole. North Pole will always be directed towards this side where the coils are turned on. At a go, 2 coils are turned on. So you can see that North Pole is directed towards these 2 coils. This is 45 degree angle. I'm talking now about the full step mode. In full step mode, the motor rotates at 45 degree angle. The motor rotates at 135 degree angle where this coil and this coil are turned on. Denoting by a circle so that you understand. Here the North Pole goes over here and the South Pole goes over here. And when I turn on this coil and this coil, then the angle becomes 225 degrees. The North Pole goes over here and the South Pole goes over here. Again, when I turn on this coil and this coil, the North Pole goes over here and the South Pole goes over this side. So this makes an angle of 315 degrees. So in a full step motor, the number of angles that a motor rotates are 135, 45 degrees, 135 degrees, 225 degrees, 315 degrees. This is the concept of full step motor, and 2 coils are being active at the same time. So now what's the half step motor? So half step motor is accomplished by full step motor, which describes the half step motor by making 1 coil active at the same time. So in half step motor, these rotations are being activated by 2 coils being activated after that 1 coil is being activated. So it's half step. So there are total of 8 steps instead of 4 steps in half step motor. Here is 0 degrees added, 90 degrees added, 180 degrees added, 270 degrees added. And last of all, it goes to 360 degree, which is not counted. We count up to 315 degree. Here total of 8 steps are there. because when we are again going to 360 degree, we are basically coming to 0 degrees. So for this reason, I am not counting that. So let's go through a figure. I will show you a figure now. So this is the figure of how a stepper motor mainly works by interfacing it with 82C55 chip. So many students try to close their book after getting this kind of figure, but no problem dear. I will be teaching you this. I will be drawing it with you so that it also becomes easy for you to comprehend and mug up this figure. Actually mug up this figure. Actually the procedure I will be showing you will also make it easier for you to mug up this figure. So stay tuned. So here now I will start drawing the figure that I just showed with you. It's interfacing a stepper motor with 82C55. So at first let me draw the 82C55. 82C55. So before starting this session, I expect all of you to know well what's present in 82C55. Even if you don't know what's present in 82C55, if you follow this video, it will be easier for you to comprehend, and that knowledge is necessary but not that necessary for this video for understanding this stepper motor. Without that knowledge, you can also understand. So just follow my video. So here is 82C55 chip. So in 82C55 we have input output write control, input output read control, input output write control, a naught pin, a 1 pin. We also have CS pin. We also have the reset pin. So these are there. Let me do something because I have to add something else over here. So this is the read pin, this is the write pin, the reset pin and CS pin. Okay, and from here the D0, D1, D2, D3, D4, 5, 6, 7. Okay, I'm not writing this. Okay. So this is the 82C55 pin. We know how it operates, right? Actually, when we give a command to 82C55 pin, the address of the command are being used to control the outside peripherals. So what are the outside peripherals? It may be a keyboard, it may be a stepper motor, or it may be any kind of device which will be controlled by this device. So how will this device know that I will be now controlling stepper motor? By getting the address. So this is another issue. For giving the address, we need some decoders. Those decoders will be connected with this code segment. So this code segment will have some impact, and there are many other issues. If you read the 82C55, that will be necessary, but for now it is not necessary. So over here you can see very well all the connections I have made with this microprocessor. This is a microprocessor 82C55. Now let's go to the stepper motor. So here port A1, A2, A3, A4, A5, A6, A7. So here similarly there will be port B to B7. Here will be port C to C7. So actually it's becoming a bit congested. My figure will be a bit congested. So now what we will do is I will consider here A1, A2, A3 and A4. So now I will show over here A1. So it will be connected by Darlington pair. we all know what Darlington pair is. Two transistors that are being connected together. Here one transistor will be connected. This is the emitter current, this is the collector current, and this emitter current will be again connected to another transistor. This is the emitter current again, and this is the base current. This will connect to the base of this second transistor. So this second transistor will go past through the ground, and here this current will go through these two coils. And these two coils, this current will go through these two coils. And this will be connected with this one. Let me do something. So actually this collector is connected with the collector of the first transistor. That's it. The collector is connected with the collector of the first transistor. So here we are getting a coil. First coil, one coil we are getting from here. So another coil. This will be obtained from A2. One Darlington pair. There the emitter will be connected to the base same way. This will be connected over here, and this will be going to here, and this will also be connected with it. That's it. The collector, both of the collectors are connected together. So next step is we need some coils over here as well. So here A3, one Darlington pair. This Darlington pair is connected the same way as other Darlington pairs are connected. Okay, I am now just seeing the other circuits and is formulating what's needed, what it requires to be formulated. Alright, so this one is done. Now A4, same way. I'm now not going in much details because you already know what I'm trying to do. Same figure, same figure. This collector is again connected. This collector is going there. This collector is going over here and giving me another two coils. So now this will be connected to the ground, and here 12 voltage supply will be here. 12 voltage supply, and here's the circle. So this is the actual figure. So what is happening over here? Only two coils are being activated in a full step. I'm talking about full step. Just remember full step. So in a full step, what's going on? Two coils are being activated at the same time. Here, like you know that in a full step, like A1 and A2, these are being activated at the same time. So what will happen? The coil will rotate towards that A1 and A2. So how will we understand that the influence of what is getting what? Alright, so here consider A1 as switch 1, A2 as switch 2, A3 as switch 3, and A4 as switch 4. So in a full step, what will happen is that switch A1, A2, A3, A4. So here I am assigning the values of A1 as like 2 will be activated at the same time. So let's assign it 0 0 1 1. So A1 will get the values 0 0 1 1. In A1 is the first step. So 0 0 1 1, it is switch 1 and 2. So A1 and A2 will be at first turned on. So for this reason the motor will be stepped towards that direction. Now if I go in the second step, this 1 will be rotated over here, 1 0 0 1. Then third step 1 1 0 0. In the fourth step 1 0 1 1 0, and the fifth step again 0 0 1 1. So this will go on and continue. So here look, this is a switch 1, this is, let's consider this as A1, A2, A3 and A4. So in switch 1, this is switch 1, switch 2, switch 3, switch 4. We are considering the combination of switches. So when it will be switch 1, A1 and A2 will be active. Thus it will rotate 45 degree angle. When it is 45 degree, 135 degree angle what we need, we need A1 and A4 to be active. A1 and A4 to be active. So like this, in this way, all the switches are being influencing a full step motor to rotate at 45 degrees, 135 degrees, also 215 and 225 and 315 degrees. So in the half step motor, the process is just mostly same. Just before there will be only one shift at a time. Here we are completing the overall shift, but when we are telling it to be a half step, like half step, there are 8 steps. How many steps are there? 4. We will convert this 4th step into 8 steps. Here we are shifting 2 variables at the same time, 2 ones at the same time. These are not variables, 2 constant binary numbers at the same time. But in half step we will only shift 1, 0 0 1 1. In half step what we will do, instead of getting 1 0 0 1, because this 1 is over here and this is going on, just this 1 will go over here, 1 0 1 0. This will remain as it is. Next step 1 0 0 1. Next step this will shift. So instead of 2 steps, I am giving it 3 steps, and by doing all the things, these 4 steps will be converted to 8 steps. That is, the full step will be converted to half step. So this was all about the video, a very long video but a very important video. If you can go through this whole video, then hopefully you will understand the full concept of the stepper motor. And stay tuned, because I will also come up with the programming concept of the stepper motor. If you are with me, if you follow my channels, inshallah ta'ala, Allah will help you secure a very good marks in your CA exam.